Okay, so GD5 here is a continuation of what you all have learned in Pythagoras theorem and trigo. Okay, so previously we have done revision of your Pythagoras theorem, converse of Pythagoras theorem, Picasso. Okay, all these are for right angle triangles. Last week we did trigo of obtuse angles. Okay, obtuse angles are basically any angle bigger than 90 degrees but smaller than 180 degrees. Okay, so there are two formulas you need to remember. That was for the previous worksheet. Okay, now for this worksheet and the next two, we are going to learn 3 new formulas that will be in your formula list. So there's no need for you to memorize anything. The important thing is to know when to use the formula and to know how to use the formula. Okay, so I'm just going to write it down here. So this worksheet and the next two worksheets, the important thing is to know when to use it and how to use it. Okay, now, so the first worksheet the first one here, we are looking at area of triangle. Okay, so just a quick recap of what you have learned in primary school. Primary school, you have learned the area of triangle, you can find it using half times base times height. Okay, so for example, if you let this be the base of the triangle, which I'm going to call B1, then the height of the triangle must be from the other corner. You draw a perpendicular line down to the base. And this will be my so-called height. So the base one and the height one is a pair of base and height. That will help you find the area of this particular triangle. Okay, now, but however, you don't have to always choose that as your base, right? You can, for example, choose this particular side here as the base, isn't it? I can choose this as my base. If I choose that as my base, then what happens is you need to find what is the height. So you're going to have to draw a perpendicular line down from the other corner. And that green color dotted line will be my so-called H2. I write it as H2 so that you can know that it's paired up with B2, that particular base and height. So that base and the height looks very different from the blue color base and height B1, H1, but both will give you the same area. You are finding the area of the same triangle anyway. Okay, now, and you can also use the other side as your base, right? So I call it B3. Then what happens here is this purple color dotted line will become the pair of the height that is paired up with B3 to help you find the same area of triangle. Okay, so don't just be very preoccupied with looking at it one way. There's actually 3 pairs for every single triangle that appears. Okay, you just have to know which one that they give you. Okay, so this is a bit of revision, but I also want to revise for scalene triangles. Okay, so this one here is what we call a scalene triangle. Basically, one of the angle is obtuse. Okay, so what happens here is if you let this be the base, for example, then the height, right, is not going to be this, okay? So a lot of people will think that this is the height, but it cannot be the case. The height must always be perpendicular to the base. So what you need to do is to extend the base out, and then you drop a perpendicular line down from the other corner. That one over here, this distance that's perpendicular to the base is going to be the height. Okay, so this is just a recap and revision of how to find area of triangle using half times base times height. Okay, but you must make sure you know how to use these two formulas first. This formula first. Okay, now I will skip the proving part. You can read the textbooks if you want. But there's another way of finding the area of triangle. Okay, and this time round we can use trigo. Okay, so now imagine with me, I'm going to call each one of the angles after the corners. Okay, so like this one here, Let's call it angle capital A, angle capital B, and angle capital C. So in a very similar way, I can call this angle A, I can call this angle B, I can call this angle C as well. Okay, so we can call this triangle ABC lah. But what happens now is, okay, I'm going to introduce how to label or how to label the sides of the triangle. So if I call this capital A, the side that is opposite it is going to be small a. Capital B, the side that is opposite it is going to be small b. And this angle is capital C, so the side opposite it is going to be small c. So in a very similar way, this is A, this is B, this is C. Okay, now, so what is in your formula list? Is this. The triangle is always half AB sine C. Okay, now, so what happens here is, according to the formula, if you take half times A times B times sine of this angle C, it's going to give you the area of the triangle. Okay, but look at what I've circled. If you notice, the angle that I circled, which is C, is in between the two sides, A and B. One more time, the angle that I circled, or let's highlight instead. The angle here is in between A and B. Okay, this idea of in between is what we call included. Okay, but if you don't understand included, never mind. The key thing you need to make sure it happened, or what you must make sure you do, is that angle C must be in between A and B. Okay, the angle that you put into the formula as C must be in between A and B. Okay, now what does this mean? This means that if you use B and C, the sides B and C, you can also, but the formula you need to put in angle A, because angle A is the angle in between B and C. Okay, so this means that triangle is also half BC sine A. This also means that triangle is half. If you want to use A and C, you substitute angle B inside, because angle B is in between. Okay, and this is very important because I don't want you all to memorize like, oh, it must always be A, must always be B, must always be sine C. Okay, because a lot of diagrams, a lot of triangles in exam, in your homework, right, it's not ABC. It's like PQR or XYZ. Then how to use this formula if you die must see A, B, and C. Okay, so the key thing is you just have to make sure that the angle that you substitute in is in between the sides that you are going to substitute into the formula. Okay, or what we call included. Okay, I'm going to pause here. All okay so far? Yeah. Okay, so let's go through one more example. Okay, so let's look at this area of triangle, this triangle PQR. Okay, so you look at this triangle over here, it's quite obvious what you're supposed to do. Okay, so the key thing you need to see is that this angle is in between this side 13 and this side 12. So to find the area, all you need to do is just to substitute the sides in and the angle in properly. Okay, but I mean, this is quite obvious, but you must always make sure it happens. Okay, so the area of triangle PQR, you sub in the two sides A and B as 13 and 12. It doesn't matter which one is A, which one is B. It doesn't matter because you times everything everywhere. You times 12 times 13 and you times 13 times 12 is the same thing. Okay, then you times sine 108. Now, make sure your angle is in what we call degree mode, but your calculator should already be in degree mode by default, okay? Because you all haven't learned a particular chapter called radians yet, which is what you all will learn at the second half of this year. Okay, but for now, all you need to do is just to press your calculator. The answer is 74.2 cm square. Give me to 3SF. Okay, so this will not be exact because sine 108 is not exact. You need to round off. Okay, there's a lot of decimal places after that your calculator doesn't show you. Okay, so I'm going to pause here first. What example one should be quite easy to understand. Basically, how to apply the formula.